Welcome to our video. The topic of today is about chemical and enzymatic methods for sequencing of nucleic acids. But first, do you know what is sequencing? Well, if you don't know, don't worry, I will give you a definition. The sequencing is the process of determining the sequence of nucleotide bases in a nucleic acid molecule. In this video, we will take a look at methods used for DNA sequencing. There are several variants for basic procedures of nucleic acid sequencing, but the most used techniques are based on the enzymatic method. The desired result of the method is to generate a set of nested fragments that are the overlapping fragments that terminate at different bases and differ in length by one nucleotide. The sequencing techniques described in this video were developed in the 1970s and are the chemical method and the enzymatic method. Before the popular Sanger sequencing came about, there was a DNA sequencing method based on chemical modification of DNA, introduced by Alan Maxam and Walter Gilbert. This method, chemicals are used to cleave the DNA at certain positions, generating a set of fragments that differ by one nucleotide. A defined fragment of DNA is required as the starting material. This need not be cloned in a plasmid vector, so the technique is applicable to any DNA fragment. DNA is radiolabeled with 32 at the 5' ends of each strand, and the strands are denatured, separated, and purified to give a population of labeled strands for the sequencing reaction. The next step of chemical modification of the bases in the DNA strand is done in a series of 4 or 5 reactions with different specificities, and the reaction conditions are chosen so that, on average, only one modification will be introduced into each copy of the DNA molecule. The modified bases are then removed from their sugar groups and the strands cleaved at this position using the chemical pyperidine. The theory is that given the large number of molecules and the different reaction, this process will produce a set of nested fragments. Main applications and relevant research findings related to this sequencing method are the mapping adenines, guanines, and thymines in RNA. The position of adenines, guanines, and thymines can be determined by partial nuclease digestion of a terminally labeled RNA molecule. The nucleotide sequencing of LAC operator. The LAC repressor protects the LAC operator against digestion with desoxyribonuclease. The protected fragment is double-stranded and about 27 base pairs long. We determine the sequencing of RNA transcription copies of this fragment and present a sequencing for 24 base pairs. Sequencing of controlling regions of the lactose operon. Other methods were created by Fred Sanger and Alan Coulson, also called dideoxy or enzymatic sequencing. In this method, the enzymatic synthesis of DNA strands terminate in a modified nucleotide. The enzymatic method has now almost completely replaced the chemical method as the technique of choice. Although there are some situations where chemical sequencing can provide useful data to confirm information generated by the enzymatic method. This method, a copy of the DNA to be sequenced, is made by the clonal fragment of DNA polymerase. The template for this reaction is a single-stranded DNA, and a primer must be used to provide the 3' terminus of DNA polymerase to begin synthesizing the copy. The production of nested fragment is achieved by the incorporation of a modified DNTP in each reaction, which is necessary for chain elongation to proceed. The concentration of the D-deoxy form is such that it will be incorporated into the growing DNA chains infrequently. Each reaction therefore produces a series of fragments terminating at a specific nucleotide, and the 4 reactions together provide a set of nested fragments. The DNA chain is labeled by including radioactive DNTP in the reaction mixture. Main applications related to this method are: more recently, a modified Sanger approach was the main sequencing engine for the first draft human genome sequence, which was produced by sequencing 500 to 600 base pairs segment of DNA infrared. The determination of the reference genomes in Arabidopsis taurina, rice, and maize using Sanger sequencing strategies constituted major milestone that enabled the analysis of genome architecture and gene characterization in plants. During the period from 1980 to 2005, sequencing platforms based on Sanger chemistry had 500 to 1,000-fold increase